Hello everybody, am I audible to you? Please let me know. Yeah, good morning all of you. Yeah, Anushka, so am I audible better? Am I audible to you? Is there any problem? Audio and video is clear to you? Can you confirm? Am I audible to you? Is there any problem? Okay. So everything is, I think, clear. Everything is good. I think we can start our class. So again, good morning all of you guys. So आप जो भी अभी मुझे लाइव देख रहे हैं, please let me know through the telegram message. And it's lecture number 8 and we are studying the classical thermodynamics. Previously we basically were discussing the first law of thermodynamics and the mathematical definition, and the conceptually we already discussed about it, right? So today we will move forward and first we revise the previous things and after that we will move ahead. So कौन live है? Please you can do your virtual attendance on the Telegram channel. I hope guys you are basically doing a very good preparation, as I already told you that your first day will be or your first day of your preparation is like, you can say that the last day of your preparation, right? ऐसा फील होना चाहिए कि ये प्रिपरेशन का मेरा लास्ट डे है, कल ही मेरा एग्जाम है, आज मुझे बुक बंद करनी है. So that type of efficiency we want if we want to get good rank in the GATE examination, right? So getting good rank in the GATE examination is not kind of impossible task, but yeah, or I can say it is not so much difficult task if we ensure some certain things, right? So what are those certain things? Like revise the subject daily, right? Get in touch with the content, right? Solving the numericals, right? If we do not skip any class, है ना? Consistency must be there, right? Dedication must be there. So if we ensure all these things, then for sure easily we can get the good rank. But if you skip anything, like if I am studying 9 hours in a day, but next 2 days मैंने किताब ही नहीं उठाई, right? So that is the basically problem. That is not going to work. Okay, let's move ahead guys. Yeah, good morning all of you guys. Good morning Anushka, Purnima, Muhammad. Let's start our class. So in the last class we have discussed the first law of thermodynamics, and we have discussed the first law of thermodynamics conceptually also and the mathematical also. So if you will talk about the mathematics, then this is the equation of the first law. This is the equation of the first law, right? And from this equation I can write this equation. Okay, I always write like this because I understand this law as that how much heat I'm giving, out of which how much work is basically done, and the remaining energy is going into the internal energy. Further, we have discussed the sign convention, which is very important. As I already told you that the sign convention is important in this formula. We basically put the sign convention, we put the values after the sign convention, right? If we want to calculate the du, then we should know q is given to the system or rejecting to the system, w is on the system or by the system, right? And after that we will put the right sign for it. Is it clear to you? So these four things are we should clear with. So heat supplied to the system, Q is positive. Heat rejected to the system, Q is negative. Work done by the system, positive. On the system, negative. Right? And you can say the shortcut, or you can say trick to remember this sign convention is, see, work done by the system, right? Work done by the system means we are getting something from the system. We are getting something from the system. So if we are getting something from others, it is positive thing or negative thing? Obviously it is positive thing, right? It is clear to you. Work done on the system, it means I have to do work on the system. It is clear to you. It is clear to you. So it means that we are spending something on others, right? So this is negative or positive? Obviously it is negative, because I have to spend something on the others. So this is how I can remember the sign convention for the work done. Again, heat supplied to the system. Let's suppose, see, heat rejected to the system. Heat rejected to the system, right? So you can say heat in terms of flue gas, in terms of anything. So heat rejected to the system is not the heat rejected to, this is how we can remember this. Heat rejected means that is my energy loss. Yes or no? Heat rejected by the system, that is anyhow energy loss for me. I want that almost all the Q will be converted into the work, right? Also it can converted it, or at least it can stored as a internal energy. I want that Q will not rejected by the system, because that is the totally loss for me. That is the totally loss for me, right? It is clear to you? Yes or no? Okay, so this is how you can remember that heat rejected by the system, it is negative, and heat supplied to the system, it is positive. If we supply the heat to the system, we will get some work, right? So this is my positive. So you can remember this thing like that, right? Okay, I have homework for you. So here we discussed that Q is converted into the heat. Q is converted into the work done, right? My question is, just think about it and just search about it and tell me, can Q is converted into W completely, or W is converted into Q completely? This is your homework. Tell me in the next class, can we convert Q completely into the work done, or can we complete W into the Q? This is your homework. So we will discuss this in the next class, right? So मुझे याद दिलाना कि हमने ऐसा कोई concept discuss किया था, right? Okay. Now, in the last class, Muhammad had a doubt that, sir, what is the internal energy? Means what is the property of the internal energy? So basically he wanted to know that what is the meaning of internal energy. This is the right words, because internal energy itself a property. So he wanted to say that, sir, what is the meaning of internal energy? I am not getting what is the meaning of internal energy. What kind of energy is this? In what sense this energy is stored into the system? Okay, let's try to understand this. So this energy is what basically? So see, this is my gas molecules which are moving here and there in the random motion. It is clear to you? So these molecules these are the gas molecules. This is my system actually, and whatever we talked about, we are talking about this my system. Means we are focusing on the gas, right? So these gas molecules are moving here and there. It is clear to you? So these molecules have some energy. What kind of energy, what forms of energy is having these molecules? First of all, as you can see that these molecules are in motion. If the molecules are in motion, so one energy is that is in this one energy which is possessed due to the motion, that is the kinetic energy. It is clear to you? So one energy basically is the kinetic energy of these molecules. So this is my molecular kinetic energy. And as we know that kinetic energy is basically associated with the motion of the molecules. Another energy is the interaction energy between these molecules. Okay, due to the interaction, another energy we define is my potential energy. So from where potential energy is come, basically if the molecules are interact with each other in any fashion, in any configuration, that is basically contained the potential energy. So these molecules which are you can say moving here and there are two types of the energy which is basically these molecules have. One is the kinetic energy, another is the potential energy. The sum of the kinetic energy and plus potential energy we called as an internal energy. We call it as a internal energy. It is clear to you? Yes or no? It is clear to you or not, guys? Okay, it is clear to you. I hope it is clear to you. So we can say that my internal energy is nothing but it is the sum of potential energy and the kinetic energy. Okay, so when we give heat to this system, we are getting some work done, but this Q is not going to convert 100% into the work done. Like if we are giving the 100 joule energy and if we are getting that 70 joule work, the remaining 30 joule is missing here. No, it's not missing here. It is stored in terms of internal energy. So when the gas molecules getting some energy from the outside, its random motion will increase. It means its motion will increase. If its motion will increase, it means its velocity will increase. If its velocity will increase, its kinetic energy will increase. If its kinetic energy will increase, it means the internal energy is basically increase. Right? So that's why we talked about it. Then when we give some heat to it and if we are getting some work done, the deficit amount is basically going into the change into the internal energy of the system. Please tell me if you have any doubt in this. Tell me if you have any doubt in this. Everybody, please tell me, because the comment for everybody is important for me. Okay. Okay. Right, this is we already talked about it. Internal energy is sum of the energies of the molecules, right, in the frame of reference, or you can say it is the sum of the molecule energies. What are the energies? That are the kinetic plus potential. There is no need to write it again. Internal energy is the solely function of the temperature, guys. Right, internal energy is solely function of the temperature. Right, what is that? How it is connected to the temperature, we will discuss. So as we know that internal energy is, you can say, I can write the third point also, that it can it is state function or it is point function. It is state function or point function. Means it is depend upon only the points. Means this is depend upon this point and this point, this initial point and this final point. right? So if we are going with the path 1, if you are going with the path 2, if you are going with the path 3, there is no issue. The change in internal energy will be same for all the 3 paths. Okay, how it is connected to the temperature, that is defined by the Joule's law. So please write down the heading Joule's law. Please write down the heading Joule's law. Please write down the heading Joule's law. What Joule's law say? Joule's law statement is the change in specific internal energy is proportional to change in temperature. So Joules is basically conducted an experiment and he found that the internal energy is basically proportional to the temperature, right? So it is solely the function of the temperature. It is clear to you? So let's suppose a specific internal energy means this capital U divided by M. Let's suppose it is my small u, which is my specific internal energy, and specific internal energy change, I will say du, is directly proportional to the change in the temperature, right? It is clear to you? So from here I can write du is equal to, if I remove the proportionality sign, it is my Cv, it is my any constant K. It is my any constant K into dt. So du is equal to k dt. Correct? So K is my any constant, right? K is my any constant. So the value should be K will be same. The value of the K should be same because it is constant. Because it is constant. But when Joule conduct this experiment, he found that K was not the same. The value of K will vary. If the value of K will vary, so we cannot keep this as a constant. It is clear to you? So he find a property which is basically that the same for all the gases, right? That is my Cv. That is my Cv. What is Cv? I will write it. So instead of K, he put K instead of K, he will put Cv. So du is equal to Cv dt. This is the relation we get, right? This is the relation we will get. So U is the function of temperature, or you can say the change in the internal energy is also the function of the temperature, right? It is clear to you? चलिए एक बार इसको लिख लीजिए. Please write it down, and after that further we will talk about it. This equation is in the for the 1 moles, for n number moles, we can say du is equal to ncv dt. Du is equal to ncv dt. Okay. Right. So what is CV? What is CV? So I hope that you guys are aware about it. It is my specific heat capacity at constant volume, right? This is my CV. The unit of CV is, you can say that it is my joule per kg per Kelvin. Okay, joule per kg per Kelvin, right? And in number of moles, it is joule per mole per Kelvin, right? Done. So can we give a statement about it? Can we say that internal energy is equal to the work done or not equal to the work done? Which statement is correct? So as we know that internal energy is my point function and work done is my path function. So this is for sure. For sure, the point function cannot be equal to the path function. Yes or no? Point function can be equal to the point function. Path function can be the equal to the path function, but point function cannot be equal to the path function, right? So my internal energy is not equal to the work done. Okay, it is clear to you? Am I audible, guys? देख रहा हूं, अरे देख रहा हूं ना. Okay. So see, what is my first law? My first law will be del Q minus del W is equal to du. Okay. So see, what is my, yeah, it's correct, it's correct. So at constant volume, at constant volume means the change in volume is zero, means dV will be zero. If the dV will be zero, then this del W will be zero, because del W is equal to P dV. Then can we say that del Q is equal to du? It means we can say, guys, we can say that at constant volume, all the heat is converted into the change in internal energy, change in internal energy of the system, because there is no any work done, piston is not moving forward. In that case, that whatever you give the amount, where this amount goes, this amount is basically goes, or you can say stored in the system in terms of the internal energy, right? I hope that this concept is clear to you. If is there any problem, you can ask, please tell me. After that we will solve a question. Please tell me that there is no problem. Now we have built some concept. Now we can solve the questions. Very good questions, quality questions we can go through, right? Okay, great. Okay, so this is the question, guys. Please read this question and let's try to calculate it. If you are able to solve this question, or after discussing this question, whatever we have discussed till now, you are very clear with it. If still अगर कोई छोटा मोटा डाउट भी है आपका, इफ यू हैव एनी डाउट कहीं पे भी, then it will be clear now with the help of this question, right? So initial state, this is my initial state and this is my final state, right? And from initial to final, there are some paths like IBF, IAF, and one path is from F to A. I hope these arrows are clear to you. Okay, right? So along the path IAF shown in the figure, the heat energy absorbed by the system Q is equal to 55 joule. So it is for the path IAF, right? So let me make it easier for you, that I'm saying that Q for the path IAF is equal to 55 joule, and the work done for the IAF is equal to 25 joule. If the same system is taken along the IBF path, means it is IBF path, means this wala path, Q will be I for